Hey guys, good afternoon to everybody. I hope you had a good time in the conference, and I hope I'm not going to ruin it. My name is David, and apologize for the accent. I'm originally from Hungary, living in the UK in the last 6 years. I work for Sky. I'm not sure how much do I have to introduce the company to you. We are the #1 telecommunication company in Europe. We have presence in Germany, Italy, Austria. We create content and we ship it to you guys as best as we can. What most of the people doesn't know is Sky is always trying to evolve their technology stack. We're always trying to use what's the best for our use case. And that's why we're here. We identified a long time ago that Couchbase is a good fit for most of our use cases. And in order to do it in a good fashion, our department created 2 years ago a Center of Excellence team. And one of the part of it is my team, persistency team, which works with any kind of data persistence technology. So anywhere where data is important to stay up to date, you are planning not to use it, that's something we are trying to be across it. So what am I going to talk about? I would like to give you a bit of context, give you a background of the evolution of the departments which Sky went through, changes in the different technologies, why we did this, what was the motivation. With this, I would like to set up what's the challenges for us and what are we planning to do in the future. So, as a background, around 2011, we started to look into the non-relational databases. Before that, we barely played with those. And the very first one which we grabbed was MongoDB. So there is tons of things wrong with Mongo, but it was perfectly fine for our need at that time. Yeah, that was weird. And it was so successful at 2011 that at 2012, we agreed department-wise that anything which is new, any new technologies, any new project which we are planning to do, we are setting non-relational databases as a go-to platform. So unless there is a very good reason to keep relational databases, we wanted to go for non-relational. At 2013, we had a department, a main group called Identity, which by the name suggests handles all the identifications across our platform, announced that they like Couchbase. They started to have a look at it, so they would like to use it. So they created a plan how to move away from their existing platform, which I will talk about, into Couchbase. But as you can see, from 2011, 2012, 2013, just like with many of the big companies, we are not so different either. Things doesn't move that quickly. Until 6th of April 2014, when the first episode came out of the season 4 Game of Thrones. Around that time, 2014, we had a limitation between 800,000 to 1 million concurrent user to be able to serve in the same time. Same times means within a relatively short time close each other. So it doesn't mean everybody try to log in 1 second, but it means it's queued up enough to receive over 1 million requests for the same video on demand. So as I said, at 2014, our limitation was about 800,000 to 1 million user. The forecast for Game of Thrones was around 300,000-400,000 top. And our scheduler team put it Premier League on the exact same time for a different channel. 2014 was fun because that was very, very close with Premier League, and that was Arsenal playing with, I don't want to lie, I don't remember who was it. But in total, what we had is this graph. The green one, what you can see is the channel responsible for the Premier League content. The blue one is the channel responsible for the Game of Thrones content. It slowly built it up until 9 o'clock when both of them was kickstarting. The blue is 500,000, sorry, the green one is 500,000 concurrent user at the same time. The blue one is 800,000 at the same time. So we didn't just went over 1 million, we went far over 1 million, which caused our bottleneck, which was actually the identity, which announced would like to go to Couchbase, didn't execute it on that time. That caused us about a 15 minutes downtime in terms of logging in. Our Twitter didn't appreciate it too much. And yeah, we kept give infinite loop for the people who signed in, and nobody was able to watch neither Premier League or Game of Thrones. That was our biggest and only downtime we had in the last 10 years, as far as I'm aware. So obviously, we fixed it. We started an initiative to move from relational databases more into non-relational, and I will talk about it why. And as I said, around 2014, we had the limitation of around 1 million concurrent customers at the same time. So in 2016, we announced the movement. What we want is move from 1 to 5 million, and I will talk about it later. And 2018, this year, we not just completed it, we're planning to complete the same transition across multiple departments, which was at that time wasn't under our guidance. So yeah, I believe it's quite obvious. As a media provider, what we want is to make sure that whatever request we receive, whatever demand we are facing, we want to make sure we not just serving it, we excel it. So after the Game of Thrones incident, which is great about this company is our management said, all right, guys, so here's a challenge for you. I want to make sure that you can 5 times of what you are able to do today, but with the caveat that you are not supposed to increase your infrastructure. So the infrastructure footprint, it means that you can use new technologies, you can change different hardware, you can change technology stacks. But you shouldn't, like in an old way, if somebody used Oracle before, you know exactly that if you had X number of customers at the same time served, if you want to reach 2x, you deployed twice as the size. You needed 5x, you went 4 or 5 times of the same. So the challenge was use the current infrastructure footprint, but get at least 5 times more of the infrastructure which we have today. So I would like to talk through how we actually achieved that with the first and the second one, and how we planning to do that with different departments in the future. So OTT is a media term for over the top. Over the top means anything which is streamed through the internet, it's represented here. The first stage is 2012. If you remember, our issue was 2014, so it's 2 years before the Game of Thrones event. And what we had a big monolithic service serving Oracle and a bit of MySQL. And that monolithic service called MPod was responsible for everything which we served over the internet. If you wanted to watch anything video on demand from any device, if you wanted to register in a device, if you wanted to log in to get your account information for that kind of service, we were serving it through Oracle. That's 2012 again. So at that time, we had a limitation based on our historical testing. It was 200,000 peak concurrency, which we were able to reach at max. And at that time, we had a 50-50 ratio in the hardware infrastructure that 50% was prod, 50% was test. Now, when you get OTT was the first who tried to optimize this even before the event. So we were in a much better position at 2014, but we constantly evolving. What we did is we broke down 2 different logical groups, what MPod was representing, and we created OVP, which is online video platform, responsible for device manager, tokens, anything to do with playing video through the internet. And we created content discovery, which is responsible for data analytics, metadata, is responsible to give you guys suggestions, building up what, if you're using any Sky Qbox, for example, what is recommending for you, what you watched before, based on that what you might like in the future. So we break it down, and at that time we didn't have a relationship with Couchbase. We looked the available technology stacks, which was Apache and DataStax Cassandra. We looked into Redis, we checked Elasticsearch, and we chose these technologies, and through the time, we constantly evolving it. So 2018 today, using the same infrastructure footprint, we reached 3.6 million peak concurrent and a changeable, but averagely speaking, 80 to 20% production to test ratio. I believe it's a terribly big increase, and we learn from this a lot. Now, at 2014, what broke was identity. That was an Oracle-based system having tons of business logic. So at 2014, we already had a plan. So after the incident, we executed on the plan. We had, at that time, 800,000 users, and that service was able to serve 1,500 TPS. TPS is for transaction per second. And we broke it down into the proposed suggestion, Memcache for session store, Big Couch for profile store, Oracle left for business queries, and OpenDG was for credentials. And later on, less than a year later, we moved everything, all of the four, back to Couchbase directly after we gained confidence enough that we know that it's going to work. So the change is using not the same even, but less infrastructure footprint. We moved from 800,000 users to 8 million. And we moved from 1,500 TPS to 12,000 TPS. The 9,000 TPS is the middle, representing that with these four small microservices, we reached around 9,000. When we merged them into a single Couchbase cluster using 4 different vBuckets, we went 9,000 to 12,000. So this is the 2 departments where we successfully made these changes. Then we have challenges ahead. We have broadcasting service, which is we currently started to review. And the reason why I'm talking about, because I would like to show to you the challenges we are going to face. What you see on the picture is very far from being the full picture, but I would like to represent that this is the kind of business logic and relations built into Oracle. And the target here is to break those down into meaningful microservices which are able to serve us in a much better way. The biggest challenge, so this is changing something which is using Oracle into something else which we are hoping to replace most of the stuff with Couchbase. But the other one, which gives you a bigger headache probably, is our digital platform. Digital platform is, if you look our Twitter account, any editorial, any news, any kind of social media communication, or the materials for the commercials, these guys are across it. Now, this is basically, and I understand you can't read it, that's for a reason, but basically, this is, think about it. Broadcasting is one of the first services which Sky started to serve, right? So that means it's one of the oldest. So you usually don't go and replace something until it doesn't broke. It didn't broke. We just reached a level when we can't keep up with it. So we have in the center, I will try to use the laser, a big, massive Oracle database, monolithic. We have a big Redis database in the middle, monolithic. And everything else around it, I can't tell you when they arrived, because what we have is single machines to virtual machines to microservices. We have here cloud providers. We have here in-house systems. We have here Oracle business logics. Everything you can imagine merged into a big piece of architecture diagram. Yeah, the problem is that so when new technology arrived, we didn't fix everything, we just took it into the existing one. So there is a lot of transformation in between. You get a new technology, you just changed a little bit, so it's not perfectly tuned, but if you did this sacrifice, then you can make sure that it works with previous services, which were not necessarily built for the same standard as your new service. So now you have so many loops with your data flow that it can't be simply just fix a big piece. We need to figure it out how are we going to build all of them into a big, meaningful service. And it's not going to be a single database. It's not going to be only Couchbase solving this for us. But we are hoping that it's be able to take a big piece of this cake, and we can leverage everything which is available or coming next. Before I'm moving forward with the story, I just want to make sure that the definitions I'm saying here, we are on the same level. I'm not going to explain to you what's monolithic versus microservice, containers versus VMs or immutable, but I would like to build up my logic here. And my logic is simple. Monolithic is a software architecture, and microservices is basically a design architecture, but they are a kind of evolution of each other, because with monolithic, you tried to build a big piece of monster, solve you everything, but it was not really scalable. Meanwhile, microservices, you're trying to break it down into meaningful subspecies, independent groups, which you can constantly evolve if it's needed. If it becomes a bottleneck, you can fix it. But you have an overhead of the messaging queue systems, independent databases, and so on. So there is a trade-off, but still, it's a natural evolution with our infrastructure strategy. With VMs and containers, again, I don't want to go into details, and very likely most of you know exactly what's the difference. But what I would like to highlight is VMs not old and containers not new. Those are just for use for two different use cases. There is a completely different target set where you would still use today virtual machines, and there is a completely different target set where you would still use containers today. They are trying to solve the same problem differently. Therefore, it's trying to solve multiple issues differently. Yeah. It didn't make too much sense. Why I did this? Because I would like to talk about infrastructure as a code. So infrastructure as a code is something where we see the next future. We would like to remove the burden from the operation side, and if we can automate deployment of systems and architecture and infrastructure, then we should. Now, today you're likely to be very aware that you can use infrastructure as a code for stateless services. What you can do is you can define your infrastructure, your piece of architecture, you can deploy it. And why we call it infrastructure as a code? Because you don't go with this methodology, you don't go and do an upgrade, you don't go and change anything after you deployed. You just destroy it and build something new in place, which you can immediately replace it. Now, it works with stateless. It doesn't really work with stateful sets, for example, with databases. So, our problem statement. You can go ahead and you can create and you can tell, you can say to any engineer that, hey, this is a challenge you're facing. These are the pros and these are the cons, which you should fix. You will be able to convince that engineer. So if you have a right mindset as an engineer and you say, hey, I like this idea, this is actually solving my problem better, you're very likely to say, yeah, okay, let's give it a try, let's go and let's fix it. But what you need to do is you need to build up a proper use case for the business. So you need to be able to show the business that something is still working. It doesn't mean that's still the right solution for your problem. Such as with, I showed to you with BSS or with digital. If something is still working, it's brilliant, but there is a line when you should cut your losses and say, hey, let's change it to something better. And that's probably the hardest part. Convince the business to invest the time and effort needed to change something which is not broken yet. Once it's broken, it's quite easy. You need to provide a fix. They will be happy to do it. Until it's working fine, the investment needs to be justified. Yep, Couchbase in the picture. Why we choose Couchbase, what are we doing with them, why we like them, why we don't like them. Basically, you had in the morning, on the very, very first technical track, you heard about denormalization of data. When you work in an environment such as ours, where Oracle is heavily present, and you are saying to a hardcore Oracle DBA that, hey, I want to take you away from relational database, and whatever you did for the last 5, 10, 15, 20 years, do it with another database. They won't be necessarily so happy. They will raise questions such as, how will we move it? How would it work? You don't want new people. You don't need new people. With Couchbase, when you introduce Nickel to an SQL-oriented person, they will be very happy because they see something familiar. They will understand what you're trying to do, and it will take them a few days to weeks to learn it. So Nickel, a sequel to Nickel is very simple. The other one is a different ways how you can actually create your denormalized data. So data denormalization means that meanwhile you work with Oracle and you work with SQL mindset, you're trying to make sure that you don't have duplication. You don't have any data present which is not needed to be there. You try to minimize the amount of information have stored. With relational databases, you know exactly it's not the case. With relational databases, you may introduce duplications, indexing, and use also joins if you need it. But what you are trying to do is optimize the query, optimize the task, optimize your data to ensure that you can deliver the task you are trying to deliver as quick and as efficiently as you can. And one more thing, the CAP theorem, stability, speed, durability, all of these things are very nicely present with Couchbase, so we really like it because you can choose which side of the CAP theorem you're trying to put Couchbase. If you configure it right, it will serve you well. So what's our long-term plans? Based on what I just presented to you guys. We would love to be able to reach into a stage where persistency layer, database layer, exists as a service, but not just as a simple service because you can do that today, but it's a self-healing service. So we wish to heavily rely on containerization, Kubernetes managed systems. And what we would like to be able to achieve later is to create a service where these databases are deployed for you. The management container service would understand the state of the infrastructure, should understand the state of the database, should understand the place and the state of the data. And as far as we can move the database as a service from the actual data attached to that service itself, as better we will be able to self-heal, self-recover our databases. And for that, we are working with Couchbase on the beta program. The management service sounds very, very promising within Kubernetes and outside of Kubernetes as well. But it's too early stage. Anyway, we see the future using self-healing infrastructure. And yeah, a quick conclusion. We have tons of things to do. We will have a lots of fun and challenges to merge our old style architectures of many different departments. We will have a lots of fun working with Kubernetes and with Couchbase beta program for Kubernetes. We need to do a lots of proof of concept around that, and we are looking forward to it. And yeah, that's about it. We need help for this, so a single sales pitch we are hiring. So if you like challenges, you know where to find me. And I would like to open up. I have 4 minutes left. If you have any questions, which I might able to answer. Yes.
So you talked about Kubernetes with regards to the support from Couchbase, but through your slide deck, you're not just looking at Couchbase as a database. You have got CockroachDB, Mongo,
Yeah. Wherever it's possible, we would love to, but it's not going to be possible everywhere. So we are looking for multiple vendors, obviously, because there are multiple use cases, and it does not everything fits to Couchbase, but many things. So we are heavily working with DataStax Cassandra. We're working with Mongo. We are have a look on what CockroachDB is able to offer you guys. We checked Aerospike. We're checking lots of different databases, lots of different technology stacks, and we are trying to understand where would it fit to our big picture. But we have a few core technologies. One of them is Couchbase, where we would like to create this self-healing environment in the future. Not everything will be able to. If you think about Mongo, you won't necessarily be able to create a self-healing infrastructure just because of the nature. It would cost you far more to try to self-heal than just go and fix it. It's really a trade-off, and we need to understand what Couchbase is able to offer, how quickly it's able to recover before we can make it into reality.
And as part of this program, are you also providing guidance to this framework for developers? Because as you said, depending on the choice of the technology you choose, it might have implications on the self-healing or the orchestration on recommendations with regards to what they choose. Because in some cases we say leave the developers to the choice of choosing for that service, but that has implications on your IOC.
You're talking about persistency as a service. Yes, so basically what we had in mind, and it's not finalized, so I'm talking for myself only, not for the company. But basically, if you give developers a choice of, please tell me what do you need it for? What kind of load are you expecting? What kind of replication factor you need? How much downtime can you afford, if you can afford any? If we identify these key areas and asking the developers to give me this information, then I can build a framework around, and I can say, hey, based on the information you provided, that's the configuration and the number of nodes and the way deployed, very likely to fit best for you. It doesn't mean it will do justice for everybody. Then we go and review it individually. But what we would like to enable is if you have a DevOps team, and the DevOps team says, hey, I need a database, preferably JSON usage, so it have to be NoSQL. I need it with replication factor of 2, but I don't care anything else. I don't necessarily want to go through the same process with them, want to enable them to choose, deploy, and forget about the database. It will work. But for the use cases where the database is the key factor, we obviously not necessarily be able to prove everything and do everything through this layer. 1.5 minutes. Anybody else? Yes? Yes.
How so? I mean, Couchbase usually accounts for the CNP in CAP, not in availability, but only in consistency and persistence. So
you're right, but based on the experience we have since 2014, we didn't have downtime with things using Couchbase, and it's very, very, very quick. And that's the two things which we are looking at the moment. That's usually the two main factors. Make sure it's available as best as it's possible, and Couchbase pass the test, and make sure it's quick. And if it's configured right, indexed right, your query is right, you have enough memory, it's going to be quick. I think that was our time. Thank you very much for everybody for your patience.